So now we're on the third page. We're looking at the segment addition postulate. And it says, given that S is between, and remember, between does not mean middle. It just means in between. S is between M and N. So what I'm going to do is I'm going to draw a segment that has an end point of M, an end point of N, and S somewhere in between them. I don't know where S goes. I don't have enough information on that yet. So I've drawn my picture. So now I'm going to start labeling. The distance from M to S is 3x minus 8. So you've got 3x minus 8. Okay? And then you've got the distance from S to N is 14. And then the total distance from M all the way to N is 4x minus 4. So what I'm going to do is I'm going to set up an equation to solve this. So I know that I need another pen. That was kind of funny. I guess not. So 3x minus 8, which is this piece, plus 14, which is this piece, is going to equal the whole thing, which is 4x minus 4. So now it's just a situation, a matter of combining like terms. So I've got negative 8 and positive 14 on the same side, so 3x, 14 and negative 8 is 6, plus 6 equals 4x minus 4. Okay. For my next step, For my next step, I'm going to get move the 3x over to the 4x, so I'm going to subtract. Subtraction property of equality. Notice what I did there. So 6 equals x minus 4. And for my last step, I'm going to add the 4 to both sides. So x is equal to 10. Okay, now we know x is 10. That's our first value. But I'm not done yet. I need to find ms and mn. Well, ms is 3x minus 8, right? So wouldn't I just plug the 10 in for x? So 30 minus 8, which is 22. So ms is 22. So now I have x, I have ms, and now I've got to find mn. Mn is 4x minus 4, right? So that's 4 times 10 minus 4, which is 40 minus 4, and that is 36. And that is mn. So mn is 36, this is 14, and this is 22. And that's how you do the segment addition postulate. Okay. If you're looking at midpoint, we use the midpoint formula to solve. Find the midpoint of jk given that this is j and this is k. Now if you remember, the midpoint formula is the average of the x's and the average of the y's. Okay, so I'm going to rewrite this. My comma is there, my plus signs, divided by 2, and let's look at the coordinates. What are my two x coordinates? 5 and negative 11. So I'm going to add 5 and negative 11 over here. What are my two y coordinates? 3 and 7. So I'm going to add 3 and 7. Okay. So 5 plus negative 11 gives you negative 6. So we have negative 6 over 2. 3 plus 7 is 10, so we have 10 over 2. And you can reduce those. So you get negative 3, 5. That is your midpoint for number 1. You're using the midpoint formula, the average of the x's and the average of the y's. On number 2, we're given an endpoint and a midpoint and told to find the other endpoint. So you've got line HI, or segment HI, and H is located at negative 4, negative 3. You don't know where I is. That's a question mark. But you do know that the midpoint is located at negative 1, 4. So how do I find the other endpoint? Well, this is pretty simple. you're just going to figure out how you got from one endpoint to the midpoint and use those same ideas to get from that midpoint, from the midpoint to the other endpoint. I like to set up columns. So H is at -4, -3. The midpoint is at -1, 4. And then I, we don't know. We're looking for. So we have to figure out what our changes were. Okay? So how did I get from H to I? Well, from H to M. My bad. I went from -4 to -1, so I added 3. Well, since this is in the middle, if it's 3 from here to here, it should be 3 from here to here, so I'm going to add 3 again, and that puts me at 2. There you go. You're already done with the first coordinate. The second coordinate, we're going to do the same thing. How did I get from the first y to the midpoint y? -3 to 4, I added 7. So to get to the other endpoint, I have to do the same since it's in the middle. So that's 11. So that's your answer. And that's how you do the midpoint, or find the endpoint when you have the midpoint and one of the endpoints. Now let's look at conditional statements. Conditional statements. If Aaron Rodgers gets hurt, the Packers won't win the NFC North. So what you're looking at with conditionals, is, what are we looking at? Converse. I'm doing converse first. The converse, remember, is when the hypothesis and the conclusion switch. So instead of the if being in front of Aaron Rodgers gets hurt, the if is going to move in front of the Packers won't win the NFC North. So when you write your converse is going to say, if the Packers if the Packers don't win the NFC North, then Aaron Rodgers gets hurt. Apologize for my handwriting. I'm kind of writing at an angle. I put the if now in front of if the Packers. If the Packers don't win the NFC North, then Aaron Rodgers gets hurt. So that's the converse. Now write the inverse of the statement. So let's look at the inverse. Remember, the inverse is when we make everything a negative. So if it's is, it turns to isn't. If it was, it turns to wasn't. So to write the inverse of if Aaron Rodgers gets hurt, the Packers won't win, the inverse will say, if Aaron Rodgers doesn't get hurt, notice the doesn't, if Aaron Rodgers doesn't get hurt, the Packers will win the NFC North, NFC North, will win the AFC North. So I just made it negative. I went from the original and just made it negative. Okay, so that's your conditionals.